Welcome, everyone, to our third episode of the OSMED Member Highlight. My name is Phnam Bagley. I am a space architect, and I also serve as the OSMED Design Chair, Chair of the Design Division. So for those who don't know, OSMED is the organization for space medicine, engineering, and design. And the mission is to advance human space exploration by facilitating interdisciplinary cooperation, communication, and access to knowledge for the global community. So we have people coming from all over the world in some of the events that we put together. We have this event that's happening on a monthly basis. We have a book club. We have some research related events as well. This event in particular is open to the public, while the most of the others are for members only. If you are interested in joining OSMED, I encourage you to go to osmed.org and scour a little bit of the website and see what we have to offer. And if you are inclined, you can join us as members and participate in how we can make the future of human spaceflight safer and more inclusive of all. So today I am incredibly honored to be welcoming Dr. Jennifer Rochlis, who is actually one of the co-founders of OSMED and serves as board chair of the organization. Her and I have known each other for a few years now, and it's been incredible to hear her talk about her background, engineering, and how she overlaps all of that with deeply empathetic point of view. We're going to talk about all of this and all of the work that she's done and how she sees the future of human spaceflight in the context of OSMED. So I'm going to read a little bit of her bio before she introduces herself. All right. So Dr. Jennifer Rochlis is a leader in human spaceflight and human system integration with over 25 years of experience at NASA, MIT, and in the aerospace industry. She now advises on spaceflight integration through her firm Advancing Frontiers, and also brings a unique perspective for her work in coaching and human performance, bridging science, systems, and the human experience of exploration. Welcome, Jen.
Thank you so much. And I'm all for seeing your gorgeous faces. So if everybody feels brave enough to unmute your video, at least, that would be great. But if not, I understand. I am thrilled to be here. I'm so excited and proud of what OSMED has accomplished in its first year. And I appreciate Phnam putting together events like this just to make sure that people can have interesting conversations. So we're going to chat, but we want this to be inclusive of all of your comments and thoughts. So if you, I don't know how we want to do logistically, but feel free to throw something in the chat so you don't lose it, so we can make sure we get to it. You can raise hands or whatever have you, but we're just going to get into it, and we'll make sure that we have plenty of time for you all to be in conversation as well. So thanks for coming.
Yeah, awesome. So for the agenda today, we're going to do some introduction, learn a little bit more about Jen and her background, and we're going to follow that with a fireside chat. And it's going to be very fluid, right? Where the conversation takes us is where we're going to go. And then we're going to dedicate the last 15 minutes for Q&A. So during this whole time, as Jen said, you're welcome to put down your questions either in the chat box, which is the little blurb, like the third icon from the right, on the right side of the screen, or if you click on the 9 little dots on the right side, there's a tool for Q&A. You can put your questions there. It doesn't matter. We're not a million people, so it's going to be very easy to do. So I'll remind everyone to put down their questions throughout the whole event. But yeah, we have an hour together. It's going to be fun. It's going to be inspiring. And yeah, hopefully it opens new lines of communication between these three disciplines that we love so much. All right, Jen, let's talk about your background. How does one become Jennifer Rochlis? Where does it come from?
Trial and error. So I think I always knew I wanted to go to space. I was very inspired when I saw Sally Ride. She was the first woman who ever walked out of the NASA building to get into the the people mover to take her to the launch pad. And I just remember watching that when I was a kid and going, oh, I didn't know that women could do that. I'm totally wanting to be an astronaut. So it was always in the back of my mind that I wanted to do it. I had other loves. I loved math. I loved physics. I had a great teacher who was inspiring. I went to a liberal arts college, and I studied physics at a liberal arts college. And that turned out to be really an influential move, because so much of the disciplines that we focused on in liberal arts were around communication, collaboration. All my lab reports were handwritten. We didn't do, it was a, technologically leaning major, but within a framework of really one-on-one communicative and collaborative learning. So it was a little bit different than a technology school, which I wound up doing for grad school. But so that turned out to be really helpful after the fact. And I left college not wanting to be a physicist. I was like, I loved quantum optics, which is what I studied, but I was like, this is not what I want to do. I really want to do space. So I left, and I didn't really know what I was going to do next because I had applied to all the physics grad schools. So I was like, I really want to go to physics grad school. But I found out about this program a little bit too late to apply. But it was a NASA Langley and George Washington University combo, and you could go to school and you could do research at Langley. And I was like, this is perfect. So I talked to the head of admissions, and he said, look, your application's fine, but you have no engineering. And if you want to go to space as a field, you really need some engineering, like true engineering. And so he said, why don't you take some classes in engineering and come back and apply next year? And I said, okay. And so I figured the best place to take engineering in the world was probably MIT. And I applied as a special student. So I wasn't a graduating student not matriculating, just started to take classes in all the disciplines that I had never been exposed to. And that was a real eye-opener for me, because physics was a great grounding place, but it really wasn't the specific knowledge that I needed to be a good engineer. So that was exciting because I took a huge broad range of things. And I was walking down the Infinite Corridor one day, ran into a spacesuit in the hallway with somebody handing out flyers. And I was like, oh my God, what is this? I must know. It was an EVA, an extravehicular activity event where they were going to have NASA people come and talk about the research going on. And astronauts were going to be there. And I have to go. So I went. I happened to meet the head of the Aeroastro department. I didn't even know they had an Aeroastro department. I went there because I was so busy taking all the basics. And he said, well, hey, come and chat with me. I'd be happy to be your unofficial advisor if this is something you're interested in studying. And I was like, great. So I went and chatted with him, and he convinced me to apply to stay for grad school. And so I applied in the spring to get it in the spring, and I got in. So I wound up staying, and that's kind of how I got to MIT. So when I first was there, I had a teaching fellowship to pay my way because all of the grant cycles had already finished coming in mid-year. So I started teaching right away. I had done teaching all 4 years in grad school, in undergrad, actually. I was teaching astronomy. And that was really fantastic because I got to TA the core undergraduate class called Unified Engineering at MIT, and that exposed me to even more of the basics. So it was a year full of getting caught up. And then when it came time to figuring out what I wanted to really specialize in, I was immediately drawn to Dava Newman's lab and her work with all the humans in space. So I focused all my coursework for master's and PhD in and it was at the time called human-computer interaction. That was the major. So I've always looked at the human as sort of a black box system, right? Things come in, experiences, environments, sensory cues come in, some magical processing happens, and then we spit out actions and feelings and thoughts and behaviors into the world. And I was fascinated with how that worked and what would happen when you put that human into a odd or unusual or stressful environment. And then what happens if the person that you are getting all this sensory information from is no longer human, but also a machine. And what does that do to our way of thinking through the world? So my view really very early on was very human-centric. What does it mean to be the human trying to interact with the world and with these machines that we were developing? So that's kind of what I studied. I wound up doing an internship at NASA as a graduate student. We were building the world's first humanoid robot. It's called Robonaut, 52 Degrees of Freedom. And I was responsible for helping them translate. They were like, we have a lot of people who speak control theory and a lot of people who speak robotics, but nobody who speaks human and controls and robotics. And that was my major. So I said, great, I can translate. So that's, one of the underpinnings of OSMED is really translating between disciplines. And that's exactly what I was hired to do. So I went to NASA for that. If we had more time, someday I'll tell you the story about how I actually got hired. But But after a couple of years of interning, I got offered a position full time, and I went before I even finished my doctorate. So I was doing my doctorate on Robonaut and finishing and working full time, and that was a little bit busy, but it was fabulous. And I wound up working in engineering robotics for many years, and I was responsible for all of the human interfaces to all the robots we were building. So lunar rovers, spider robots, Robonaut, humanoids, new ways of doing AI in terms of automated vision, new ways of doing AI in displays for fault detection and recovery, figuring out how to operate the space shuttle robotic arm from the ground for mission control, which they never let anybody do before. So we were doing some astronaut trials to convince them to let them operate while crews were asleep, right? So a lot of really fun projects that I got to get very messy and hands-on with. And then I also had this parallel kind of launch through the management chain. Mostly I attribute that to my liberal arts background. I was one of the few engineers who could speak to humans and really relate. And I really loved the caretaking and helping and supporting and championing people and developing people. And most of the leaders at NASA in my day were the ones who had been there in the technical positions the longest, not necessarily the ones who were best cut out for management. So I was unique in that way. And so I moved very quickly kind of through the ranks. I did various roles at NASA over the 20 years I was there, leading science teams, leading engineering teams, going back and forth between the human systems side and the engineering side. I was associate for HR for a while. I mean, I did all the things. And that was fantastic. Got a call from my PhD advisor from MIT and said, "Hey, Rochlis," he's like, "Have you ever thought about leaving NASA?" And I was like, "No, why would I do that? This is my dream job. Like, I've been here 20 years. I would never do that." And long story short, he kind of convinced me to explore other options. And I said, why not? I've only ever had this one job. What else could I learn? So I followed him up. I managed to get a job in industry. It was doing solution architecture. It was this company had bought up 4 independent companies doing various robotic and human tech and AI and said, "We need this to all be one ecosystem. Can you figure out how to put all these things together?" And that's what I had been doing, was integrating my whole career. So I did that for a few years. I learned so much that I didn't know.
Alexa, turn on Sky.
First time I was ever allowed to make money legally for a company. I didn't know that was a thing. Like a balance sheet and a cap table and a revenue generating this and that. I was like, I don't know what that all means, but I was very green at all of that. Learned a lot about being on the product side and developing for customers from a product space, from a revenue space that was terribly new. But it was also terribly toxic, as it turned out. So after 5 years of that, I had already started a coaching business on the side personally. And when that job ended, the stars aligned, and Eric, who's on the call, and our co-founder Dara, we were all, available at the same time to start reimagining how we could give back to spaceflight, given the massive shift towards commercialism that had happened during our tenure. And we said, we learned so much and we would really love to give back and help them really streamline their processes, streamline their ways of thinking through the problem, making sure they're thinking of the human all the way through, making sure it's cost effective and sustainable. So how about we form and storm and go do that? So that's my 5-minute ramble of how I got here, but I'm sure I missed a whole bunch of fun things and talked more about some things than others.
That's wonderful. One thing that really strikes me when you talk about your background, which is fascinating in every way, is how many times you said yes, how many times you were curious. I want to reach something. How do I get there? What's in front of me? And just do it. I didn't feel any fear of like, oh, I can't do that. You just surrounded by yourself with the people who could help you, who could guide you, and then you just did it, which is so wonderful to see. And look at you now, doing what you love and doing it with passion. Another thing that's very striking in the way you talk about space, for as long as I've known you, is how inclusive, jargon free. You call yourself as translator. And that's very, very true. And that's what makes you such an incredible, like one of the best people to like found an organization like OSMED, because really that's at the at the core what the organization is about, right? When you go to all the space conferences, people are throwing acronyms at each other, and you're always the one calling out people like, what does this acronym mean, to make sure that everybody in the room understands. And I truly, truly appreciate that, because more and more people are interested in joining the space industry, are interested in the non-traditional disciplines that we need. The people who make food, the people who design, the people who think about the psychology of astronauts and all that. Not necessarily the engineers and the astrophysicists of the world. How can they be part of the club in some ways, without being intimidated by the language that we use every day? So one of the quotes that you said earlier is that you are one of the few engineers who can speak to humans. So true. um, to this audience that we have today, could you give us, 3, 4 tips for engineers who are already very passionate about space? How can they speak more to humans?
Happily. And I'll say, not everybody loves to speak to humans, so that's okay too. I think that part of the thing that you learn when you're leading very diverse groups of people with expertise. When I was the first branch chief, I had people who were up and comers, wanting to climb, wanting to lead, wanting to do. And I had people who'd been there since Apollo who were like, don't move my cheese. I'm happy where I am. I love being a technical expert. I don't need to be a leader. I don't need to be this or that. I'm me. I love this piece of work and I want to keep doing it. And I was like, fantastic. Let's clear any roadblocks you have to doing your work fully in any way that you can. So first I'll say, I don't believe that there is a better or worse if you want to be someone who wants to be interacting with people on a daily basis, even leading them Sunday or not, right? Everybody has their place of genius or zone of genius. So for those people who do want to and value that sort of personal interaction, and you've been very trained in a discipline and want to start to translate across, it's a lot more listening than talking at first. Like any good position, right? You're sort of listening for the cues as to what are they saying, how are they saying it, what aren't they saying? There were a lot of times I could point to in my career where we did massive shifts in the programmatics of systems going to space because I was in the room listening to people talking past each other and went, hold up. This is what they're actually saying. This is what's not being said. Are you saying that? Is this what you mean? So it's staying curious. You mentioned that word earlier about being curious, and it's absolutely that. It's listening with curiosity. A lot of people listen with the intent to respond, right? We've all heard that trope before. Listening with I'm ready with my next comment. I'm ready with my perspective. I know a lot of us go to lunch or something with friends and they tell you, oh my God, this happened to me. You're like, oh my God, me too. Let me tell you about my side of that story, right? And we don't hang in there with the person and let them actually have the floor, so to speak. So there's a lot of that, which is really learning how to gain perspective from someone else's words, body language, emotion, and all of that. And that is a skill you have to develop. But I do want to mention it's a super astute, as you are super astute, noticing about saying yes, because I do talk to a lot of STEM students about saying yes. It takes a lot also to learn how to say no. And that's especially true as people who have a lot of demands on their livelihoods, not just careers, but family and home commitments and life commitments and all these things. Learning to say no it's a whole art form in and of itself. But certainly there was a point where I was willing to try anything that sounded like it was in the direction of something exciting, right? Everything that I came upon that I said yes to, I was like, yeah, what's the worst that can happen? If I waste some time, I learned something from it. I learned something from everything, all the things that went well and all the things that didn't. And that includes learning how to talk to people. I have made some big mistakes in my career about how I talked to people in the wrong way, how I brought things up I shouldn't have. I was trying to do right and I didn't do it very well. And that's all part of it, right? It makes me a better engineer when I can learn what doesn't work just as well as what does work. So I was just grateful for the opportunity to kind of wring some of that out in my younger years because it served me well later on. But yeah, so tips, listening with curiosity, asking follow-up questions. Don't just immediately jump to your side of the story. Repeat it back to someone and go, this is what I heard. Is that what you meant? More times than not, they're going to be like, well, yes, but this is what let me say it differently, right? So giving somebody an opportunity to really make sure that they've been heard, because then if you come in with a different perspective, their whole demeanor shifts when they feel like, oh, at least she heard what I said, even if she doesn't agree with it, right? If I feel like you didn't get it, I'm going to keep talking over you until I get my message across, even if I say it 10 times and I still aren't effective at saying it, right? So yeah, those are some tips I would say off the top of my head.
Wonderful. Take notes, everyone. We need a lot more of that in not only the space industry, but really every industry. That's wonderful. Jen, earlier you talked about the human-computer interaction work that you've done with David Newman, MIT, the AI work that you've done. And because your work is so focused on humans, which are a spectrum of infuriating to beautiful, how what kind of wisdom can you share on how to best create that interaction between the human and the computer?
That's a very rich question. Okay. I would say you want to start with intent. This goes, okay, now almost everything I'm going to answer about human computer is you can parallel that to human interaction, trust, biases, calibration, all the things. So just know that everything I say, parallel it with all your human people. Intent is the first thing. What is the purpose of building this machinery? Is it to help we used to call it dull, dirty, dangerous, right? Offloading tasks. But it really sounded initially in the early years, in the late 90s, early 2000s, like I'm going to build something that makes my life easier. And more, I think the conversation is shifting to, well, how can I augment what I can do, right? And both of those are kind of within the same realm of conversation, which is if the intent is that my interaction with this machine or computer interface or robot is going to make my life easier or create a better 1 + 1 = 3 outcome, right? Something better than I could have done myself, then fantastic. And there is a burn-in phase that we do with people that we also do with machinery, right? So people talk a lot these days about trust with AI, trust with interfaces, trust with machines, and it's becoming more and more prevalent every 5 seconds with AI and ChatGPT and agentic AI and all the things. And there's a calibration phase that happens, whether you're talking about a human interaction or computer interaction. And that requires that you learn how it operates and how it fails. When it doesn't operate, what does that look like, right? So you can think of a myriad of people that you've worked with or people in your family, and you pretty much know how they operate. And when they operate outside the envelope that you expect, that's when you get distrusting. You're like, so-and-so always shows up early for meetings, and now they've been coming in really late and tired and sloppy, and they're not ready. And now you start to lose trust or faith in that person because they're operating outside the realm of what you understand them to have as a boundary for themselves. Same thing with machines. We need to understand when and how they work. And that's where the transparency in AI comes in, right? The explainability conversations specifically. When we built the humanoid robots, it looks like a human, but it can move in far many more degrees of freedom than I can move. It can have 360-degree exorcist heads and joints that do all sorts of things that mine don't. So I have to get used to that. I have to understand as an astronaut partner working next to a robot that can reach farther than I can, that can go behind its head, that can do all these things that I can't, not to be afraid of that, but to say, oh, okay, that's how it works. And now how does it work when it's not working, right? What does it look like? Now, a lot of the early and current failures in automation with response to aviation, for example, is when we don't do that burn-in phase or we don't allow the humans who are interacting with those tools to understand how it looks when it fails and what its boundary conditions are. So when the Boeing 737 MAX happened, one of the many issues in that whole domain was that they never trained the pilots to understand or appreciate what the automation was doing. And they figured if it was seamless and perfect, they won't even know it's there. It'll be better than anything. And that's a huge mistake because we need to understand what it's doing. And we knew that before that happened, but we just forget the lessons sometimes. And that is why I've always pushed for any time of human-computer interface early and often. You got to get it out there in the baby infant phase. I fully stand behind that we let ChatGPT stay hidden way too long. That should have come out way, way earlier in beta when everybody could have started to get some burn-in time with it before it was super sophisticated and jumped right to fear. And we also need to understand how it fails because all computer interfacing does is change the nature of errors. It doesn't remove them, right? So when you think human plus system equals outcome, or we always like to think of a human as part of the system, but for this argument's sake, right? Human plus computer or interaction or software, hardware. And whatever that outcome is, that whole system together, right, behaves differently than just the human. And we think we've developed this computer to be fantastic. We think we understand what it does and what it's designed to do. But however we decide to use it, it's going to come up with a whole new world that we've never even a priori thought about. So we have to be knowledgeable of that before we're designing it, and also the intent that we're building into it. So I'll pause there because that's a lot, but that's where I would start with HCI in general.
That's wonderful. Wow. So many nuggets of wisdom there to apply to all of our disciplines, whether we were designers, engineers, or working with humans one way or another. Um, Now I want to switch the conversation to timelines. As we all know, anybody who works in the space industries that understands that things don't happen overnight. It's not like you have an idea, you build it, and 2 months later it's happening. We work with very long timelines. To give you an idea, like the ISS, I believe, was designed in the 80s, built in the 90s, launched in the 2000s, been up in space for 25 years. So during that whole time, incredible advancements in technology and understanding of human interactions have happened. So how does an engineer or someone who works around engineering in space deal with that?
Yes, it is tricky. So one of the ways that engineers can deal with this is the art and science of requirements writing. So, and I say art because this is where, designers would appreciate this, right? It is not just a science of requirement writing. It really does take some art to it. There are great classes, books, allegories that I could share someday about all the ways that you can write requirements poorly. And we've all probably lived with systems that have poorly written requirements, but requirements are like the engineering Bible, right? When you asked earlier about how to communicate with engineers, one of the first things you could do is understand that they are beholden to the requirements. Like if an engineer is working on a program or a project to build a product or service, they have a book of requirements that they have to go and live within. And when they can't interpret it, when they don't know how to take that requirement language and turn it into something in physical form, that's where all of the miscommunications can come in. So a designer can come in and look at something, or a medical physician can come in and go, I need it to do this. I need the widget to do this for me. And they're going to have in their mind perhaps a way that it could do that because they've seen one terrestrially, or they've seen it work or not work in other forms. And they're going to say, this is how we need to do it. But when you overprescribe, you then completely cut off innovation, right? If I overprescribe everything, then I don't get to be super creative. But sometimes that's okay, right? If I just need the handrail to be blue to tell me I'm on the outside of the space station, then just tell me to make it blue. Don't write a fancy requirement that has to have me guess how to make it in a color that is reflectance of this and luminosity of this. And just don't overcomplicate. So that's the first place we look for those kinds of those interfaces, because the timelines then, right, everything matures as the requirements mature. As you start to develop them, you start to see, oh, I tested that, I'm trying to do that, I'm not getting where they need me to go. And at the end of the day, the interesting thing is we can still meet all of our requirements and develop a crappy design. Like, just because I checked all the requirement boxes doesn't mean the thing that I built meets the intent of what I wanted in the first place. And you guys as designers know that more than anybody, because we don't write design requirements very well, right? So I know that wasn't exactly your question, but I think timelines, because of the way that the systems engineering process works, and you have to start so far back with the requirement, it can morph a little bit. But I will say the government has been challenged for a long time with, how do I fly something that is today's tech, right? If the requirement isn't written to be able to use this new tech as a way to solve that requirement, they won't fly it, right? If it hasn't been proven. So the commercial space is really exciting to me because there's a much faster timeline and turnaround. And we used to call this discovery science or discovery tech, right? Can't we just fly a whole bunch of tech and just see what it does? And it was so hard to do that because of this timeline and this entrenching into the world of requirements. And so sometimes systems engineering can be a little bit defeatist for that purpose. So I think one of the things that we as an OSMED community can do is start to find inroads and routes for this conversation to explode onto the actual space scene and go, let's just have some missions devoted to trying a bunch of stuff and seeing what works and what doesn't. And is this something that can actually meet this intent without having to way over design it and go back to the drawing board? So I'd love to see us get better at that, for sure. It's a killer.
for sure. Um, Absolutely. So if we apply this thinking to a future mission, coming back to the moon, going to Mars, and all the very ambitious missions that are on the roadmap, um, what do you think are the subjects we should be spending more time on?
Hmm. Um, so many. Okay. Um, I will I will start with what I personally feel is my number one, which will be obvious to anybody who's ever talked to me before. But it is the human centric pieces. And what I mean by that is you could argue the whole thing is human centric. But it's I don't feel like the long poles are technology based. I don't think that we're technology limited in doing these missions. And certainly, if you were around the Apollo era, you would say for sure that's the case. I have more power on my cell phone than I did on the moon, right? So nobody can tell me we don't have the ability to do it. Um, However, what we are not really skilled at is understanding what happens when you put a small number of humans together on long duration missions. So all of the behavioral health, all of the teaming and the cohesion. Um, we had various names for this at NASA when we used to rank our risks of going to Mars and doing long duration missions and what really needed priority. And it was the hardest sell to get people to buy into the idea that this warranted more research and more study and more engineering because it seemed amorphous to folks. How do I engineer something to make the team work better? Well, boy, that's a question that we've got to figure out, right? So, you could argue whether or not humans are an engineered system or not, right? But in the eyes of a program or a company, we're not. So they're like, well, I've got what I've got with the humans, right? What do I need to build around it? How am I, and I had this conversation with people often because it's one thing to try to research and research and research and research and find the mechanisms and the underlying root causes of the problems and the challenges, either on the human side, the medical side, the technology side. But at the end of the day, as an engineer, my question is, okay, great. What can I do about it? Can I do something about it? Can I do something operationally about it? Can I do something physically about it? Can I build a system to mitigate that? Can I create some way of solving that? Right. So radiation is always the common example, but you just use it as a descriptor. Um, Great if I understand the exact mechanism by which radiation is degrading our cellular health and our overall wellness and well-being. But as the engineer, I'm going to say, great, what is the requirement I'm writing to help me manage the long-term risk of radiation, right? Do I do something operationally like duck and cover, right? Water shield, pull all the things on the outside, make myself a little cubby, like an igloo of stuff so that I don't get impeded with the rays as much, do I design an engineered system to help me shield clothing that can reflect, right? Whatever, I don't know. I'm making things up, right? But I'm saying, what is it that I'm going to design? What am I going to build? What am I going to bring? And what am I going to do in flight that will solve this issue for me? So on the technology side, we kind of fall back on that. But when it comes to humans, we really feel like we don't know what the hell we're doing, right? I don't know how to manage your crisis when I'm, a million miles away from you. You're going to have to do that on your own. And the skill sets, because I watched from behind the scenes at NASA, the skill sets they were choosing for psychologically have morphed over time, right? It used to be do the thing we told you to do and do it with a smile. And nobody complained because nobody wanted to get told they couldn't fly again. So we never recorded human errors and mistakes in space, which loses so much data. So right now we have a really hard hill to climb by saying this is important because for years and years, we've never let anybody fail in space that way so that we could tell you, no, people will fail and we just need to, we need to do things for them, right? So that's been a big challenge there. And I think that um, we are at the cusp. We have so many smart researchers working on this, but for some reason, the uptick into the programmatics has been met with some standoffishness and maybe fear around not understanding what they could do or feeling like it's a problem that's not so techy. And so I don't really want to put it on my list. But boy, other people on this call can speak to that. But it's been a battle. And it is, to me, the number one challenge, right? We have to create a crew that can survive not only physically, but mentally and emotionally and be productive and have an experience that they're willing to bring back to our planet and share in a positive way, right? So much of space exploration has to do with how it's received on the back end. And if we create people who are incredibly ready to kill each other by the time they get back and don't ever want to talk about space again, that we haven't done our job. They might have lived, right? But what's the point?
Yeah. So you opened this big can of worms, the word resilience. resilience of systems, resilience of humans, um, resilience of how these different systems work together. I know that resilience was a huge theme in the first OSMED conference that we put together in Maui. Could you cover a little bit of how, as an engineer and as someone who works so closely with human systems, how can we optimize the resilience for future missions?
Yeah. And so first thing as an engineer, I'll tell you that we never like to use the word optimize because you can't ever verify that anything is optimized.
I know.
So, um, that is a great question because one of the things we did at the OSMED conference was even start with, well, what does resilience mean to you? You know, fill in the blank as your perspective because it means something different to everybody. Um, to me, if you want to get super nerdy about it, I'll say, you know, there's some sort of a baseline of either operation of a system, of a person, of a human. And resilience to me is the ability to flex and swell with whatever ups and downs come at that system over time, right? So, in the engineering realm, when we have a technological system or a software system, hardware, software, that is built, we have very tried and true ways where we say, is this critical enough where if it fails, we're going to have a really bad day? We need a backup. We need a duplicate system. We need a dissimilarly redundant system, meaning a different way to accomplish the same thing. So let's say, for example, just using a silly example, there's a power need and I've got batteries, or I've got a plug into the station or something like that. But if the power goes down, I need another way to get power to that. So I can fly another cable just in case it's a cable problem, right? But what if it's not a cable problem? Maybe I should fly a set of batteries. So I use a completely different tech to provide power, but I'm betting that both of those systems aren't going to fail, right? So you put these kind of systems in place from an engineering standpoint to say, let me make sure that for critical systems, which it's important to know which ones are critical and not, which ones you can live without. That's a whole exercise onto itself. What requires a backup level so that we can have resilience. Okay. When you talk about, and then there's also flexibility just in how you use things, for example. So from a design standpoint, anybody who's lived in their house long enough has moved the furniture around since you moved in, right? At some point, you're like, I just need to make my space look different. I thought I wanted it this way. I really want it this way. You've moved your desktop around, you moved your office things around, right? Over time, we just want things to be a little bit different in how we really go about using them. And we're not going to be able to ahead of time think of all the ways exactly they're going to want everything set up. So do you have some resilience in how these things can be adapted for what you need in the moment, right? As you learn more and go through the mission, that can be done. But resilience for humans is it's a whole other science, right? It says, we talk a lot about nervous system resilience, right? I've got a baseline of homeostasis that's really pleasant to my body. And I want to be able to float between parasympathetic and sympathetic nervous system responses and be able to live the high highs and the low lows and come back to baseline. And I think those are things that we are challenged with as humans walking around on the earth, but also our baseline shifts when we go into space. So how do we monitor for that? How do we take care of that? How do we give people the tools for that? And I think that's going to be one of the biggest challenges is what does it look like to build resilience in teams that are going through very complex missions in high stress environments over long periods of time where they're likely stressed most of the time and they have very little wiggle room. Like if you're in the sympathetic state for a long time and you're already hitting the ceiling, you don't have a lot of resilience. You don't have a lot of bandwidth before you burn out. So, and we've seen this, right? In some of the analog missions we've done terrestrially, we've seen factions, we've seen burnout, we've seen isolation. Like this should not be a surprise to anybody, but how we actually manage for it and optimize it, I think measuring it and talking about it are the first two steps, right?
Yeah, and you're opening the door to a very interesting subject, which is the culture of the human systems, right? For a long time, we have sent humans who fit what we call the right stuff, people who had like high levels of resilience, were basically superhuman in many ways. But the future of human spaceflight is opening the door to people of different backgrounds, different sizes, different health level, different, understanding of homeostasis, as you mentioned, and a lot of these people are not necessarily aware of where their state of health is either, right? Like they might feel like they're healthy, but are they healthy to go to space for a few minutes, for a few days, for a few months, or end up on the moon in a few years from now? And so there's a lot of research that's being done, as you say, in analog missions. Um, I just came back from an analog missions on Devon Island about a month ago with the Mars Society, and boy, did I learn about humans. And
We sure are.
I mean, everything from, we all had the same training, and some people found a way to forget very essential equipment to bring with them, or, there was an evacuation. I'm not going to go into details to why, but like it happened to the least, yeah, the last person I would think it would happen to, someone who's been to many missions. So there's a lot of like unpredictable, um, like situations that you have to deal with, and really the resilience you're talking about is so incredibly important, and culturally also, you know, for a long time, in order for astronauts to continue flying, they had to hide the fact that certain things went okay. Perhaps on the state of their mental health, perhaps on the state of their interactions with others, perhaps on the way it felt to go on missions, come back, and being lined up for another one. So yeah, changing that culture to be a little bit more, a little kinder to the spectrum of who we are as human is very much part of it. And that's why design is so incredibly important, because design by nature cares about human-centered interactions and human-to-human interactions as well. So yeah, things to think about. All right, so so it is, in about a couple minutes, we're going to start opening the floor to questions. So to remind everybody who perhaps has joined us a bit later, we are talking to Dr. Jennifer Rochlis, who happens to be one of the co-founders of OSMED. And actually, I'm going to ask this question: what are your hopes and dreams about OSMED?
Mm.
Yeah.
Hopes and dreams. My hope is that everybody who learns about OSMED and feels like it is a place that they want to come and collaborate within, really brings that compassion, curiosity, and openness to the table, because I think it's sort of self-selecting as an organization in that way, right? We say in the beginning, like, this is for all of us to get together and talk across disciplines and with folks that have different perspectives. And I think people wouldn't be drawn to it if they didn't feel like there was something they could learn from somebody else. And I certainly feel like I'm learning every day, all the time. And I always tell anybody who I'm mentoring, if you're the smartest person in the room, get in a different room, right? Like, you don't want to be in the room where you know the most, right? For more than a few minutes, maybe, to be able to impart some wisdom, but then go somewhere else where you're green and you can learn something new. So there's a real zest for the passion behind putting humans in space and doing so responsibly. And I believe that we have a lot of work to do in inspiring the next generation. I think that there's a real valley of death in terms of waning interest in that. And I think that for those of us at all stages of career, which is what I love about OSMED, is that we hit folks in every level and stage of career, that it is such a unique opportunity to really cross-pollinate everybody in one room and say, yeah, I don't know it all, but I'd love to hear what you know, because that sounds fascinating. And I think no time on the planet, I'll just say it this way, no time on the planet needs more people to be open and compassionate and listen to one another than now. So this is a human effort, right? This is not about a particularly select group of people anymore, which I think is beautiful. You alluded to the fact that the diversity of the people that we're flying now, and thank goodness, right? So and like I said, this is about exploration for exploration's sake in some cases. If somebody doesn't really believe that we should just be doing it to do it, I can't really convince them. But I do believe it's to go and have a human experience and bring that back to the world, as well as all of the wonderful things that we'll develop to make our lives beautiful and wonderful on top of that. So I hope that OSMED is a place where we can continue to do that. It's a place that people look to say, I wonder what they think about this. I wonder what this community has to say about it. I wonder what they're recommending for me to take a look at or read or learn. I wonder what they're willing to share with us today about something that they've discovered. And we're all willing to just not know it all, so that we can really say, well, how should we do it maybe? Like, if we I hope for those of you who are joining us as part of the organization and come to some of our events in person, the feeling of those events is so different than anything I've been to in my career in terms of the willingness for people just to say, "Well, I don't have a clue." Like, who else knows? Who else can share? It doesn't matter where the idea comes from, and that's the beauty of it, because we need them all on the table. So that's kind of what I hope.
That's wonderful. And one thing that OSMED has put in place since the very beginning is, how do we welcome international kind of like interaction with OSMED, because OSMED can perhaps feel a little bit US centric because a lot of things are happening in this country. A lot of the people who are leading our teams are based in the US, or at least North America. But there's a lot of opinions and a lot of ideas and a lot of traditions that come from all over the world that can really enrich the work that we do in space medicine, engineering, and design. One of the things that was put in place, for example, is when you become a member, there's a scale of cost for membership, depending on where you are in the world. So, it's something small, but it's a great place to start. We're also putting together some of these events online, making it possible for people in different time zones to participate, come listen and ask questions. Obviously, not everybody can come to our conferences, which are at this point like very limited in size, but eventually, would love to see students and professionals from adjacent industries to the space industry to come and participate in the conversation and really again enrich what we do as creators. All right, so now it's time to open the floor to questions. Let me see. I haven't opened the thing yet.
Here has one. Has got his hand up.
Okay, fantastic. Xavier, please, if you can, turn on your camera and feel free to ask your question.
And or unmute.
Okay, I'm sorry. I was having problems with this, but okay. In fact, I might need to restart this whole thing. I can't find anything.
We'll be here, so
Okay, I'll do that. Thanks.
we'll come back.
Okay. So while Xavier is dealing with technology, let's have Martina ask her question.
Provide us a few examples of the projects you know.
I can barely hear you. I can tell your microphone is on, but it's so faint I can barely make the words out. Okay, no problem.
We welcome everybody else to also either ask the question in person or type it in the chat. This was such a rich episode. Thank you so much, Jen, for sharing your wisdom with so much generosity. All of us learned something. Whether you've been in the space industry for 30 years or you're just brand new to it, that's what I love about talking to you. And we need more and more people to do that. And I think OSMED is the right platform to develop that kind of skill.
Thank you for that. Thank you for putting this together.
Is it
Yes.
is it better?
Yeah.
Yes.
Yeah, okay. Can you please provide a few examples of the projects you have been involved in recently and what's coming next? Like what you can talk about?
Yes, what I can talk about. That's a good caveat. Okay. Okay. In the aerospace world, and I'll talk about some in the AI world too. I could talk about more of those. So I would say I'll do a general piece about the aerospace work from the consulting side. There are a couple of challenges that some of the newer companies are facing, and not even the newer companies, all companies who are in the commercial space are trying to accomplish. They are at the intersection of advancing space tech, but also they're a business, right? So there's this healthy tension between making money and being a company in that sense, but also providing a service. And I think that we are helping them to be educated around the hidden costs of humans throughout their development processes, right? And so it's not just astronauts, it is all the humans that you look at across the life cycle of a system that it takes to build it, maintain it, operate it, dispose of it, right? There are fleets and fleets of humans that it takes to put 4 people into space. And there are costs to that. And I think that helping to teach folks about that and what the ramifications and where they can control those costs is important. And that's some of the work that we're doing. Some education around how they can scope and size their systems. So, for example, if you have people of all different walks of life flying and you don't know their initial health or what their few minutes to few hours to few days of spaceflight will do to them, how am I as a commercial company supposed to size my medical system? Like, how much do I really need to provide? And so that's one thing that we can help them with, understanding requirements, kind of going through and understanding what they need, what they don't need, how to scope and size for their particular mission space. So that's kind of one thing that we do on the consulting side. On other projects that I'm doing in and around AI is looking at trust in AI systems. There's a book chapter that hasn't quite come out yet about some of that work. And I'm also helping with an AI system that will be deployed hopefully in the Ukraine to help mental health because it's a huge crisis there. So how we can really build human-machine interfaces in the advent of AI in that space. And then also looking at what we need to do in spaceflight around that. What kind of systems are we trusting and outsourcing to AI, especially around human counterparts, right? So one of the things that has been discussed for many years is building an AI therapy bot, right? There are some already on the market that are starting testing. There's concerns about escapism and things like that. So that whole arena is kind of ripe. So that's kind of there are other things I'm doing that I can't talk about openly, but I will say what's coming next. I think right now the space industry is having a little bit of an identity crisis because of what's been happening to NASA lately. And it is going to take all of us to figure out what the space economy, what the space ecosystem, what the space future looks like when the government isn't the only game in town. And when now, how do they shift and what do they provide in this new ecosystem that the commercial companies cannot provide, right? And we talked about multiculturalism, but no one country can afford to do a Mars mission by themselves. So this is definitely a global effort, but I don't think that we've ever worked that way. It's been the U.S. leading in the commercialization space, and we're sort of understanding what other companies and countries are trying to do, but I think that needs to get more consolidated. So I see what's coming next is really understanding the globalization of that. There are things we could talk about in terms of commercialization and monetization and all of that. I'm less interested in that than sort of the real humanistic challenges of working together in those new ways, because technologically speaking, every 5 minutes there's something new coming, right? Does that answer your question, Martina?
Yes, I have a bunch of follow-up questions, but I know other people want to ask questions too, and time is short, so I want to give space to others as well.
Okay. I'll come back to you at the end if we've got some time. Absolutely.
Yeah, and I know Javier has something soon, but I think he's not here, so...
Okay. Speaks out. If anybody knows him, you can have him reach out to me. Just text me his question or email it to me, and I'll be happy to answer.
Yeah.
Sounds good. David, would you like to ask your question?
Yeah, so I have only just heard of your efforts with OSMED, and that's thanks to Martina there. I saw some information about your, I guess, your goals with like supportability and maintenance and so forth. The old 20-80 rule about 80% of the support cost being set by 20% of the design, which, by the way, we used extensively in the ISS proposal, and it was actually wasn't even named Freedom at the time.
Alpha 1 or something like that, right?
I'd like to hear a little bit more about your goals with that aspect of OSMED.
Yeah, absolutely. So this is under the umbrella of what we teach and talk about human systems integration, HSI, as specifically how I teach it throughout OSMED, or how I share it throughout OSMED. And there are many ways that you can get to the sustainability piece. But it basically looks at, and you kind of cited some of it, and we've shown some. I think it's probably on the website already. But there's a very famous graph that we show all the time, which is an NCOSI graph. It's the International Systems Engineering Group, and it shows the committed costs of your program over time, and then the life cycle cost as a result of what you've committed. So to your 80-20 point, right, by pre-phase A ending early phase B, you've committed to 75% of your life cycle operating costs by the design decisions that you've made. So everything early and often, which we talk about, means what are we doing at the outset to really control the costs on the end? And we know the shuttle, right, never reached its cadence because they didn't design for the maintenance, right? That thing was a mess to go in and you have to dig out the whole guts of it to change from mission to mission. And they're like, oh no, 2 weeks, it'll be great, right? So they didn't design spaces, tools, access points, hazmat gear, like, but they didn't do any of that work. So that wound up costing them way more, not just in money, but also in, actual science. So we're talking about that aspect, right? It says, what do we have to think about early on? And I'll tell you, we got some pushback at NASA when I was putting this in place. I would go to the mission control folks and I'd say, we're building this widget for Orion or building this widget for Gateway or Constellation. Thanks, Eric, for putting that in there. We want to understand what it would be like from a mission control and a training perspective. What would it be like to have, what do we have to think about in terms of training this, right? Because training is always the garbage bag that everybody throws everything into when they can't fix it in design, right? So they're like, oh, that's going to be a problem. We'll just train them to do it or not do it, right? But let's point to all the accidents and human casualties that have happened from people just training it out of the system. So we bring them into the room and they're like, I don't know what you want me to tell you because I don't know. If you can't show me the widget, I don't know how to train on it, right? And I'm like, no, but you do. You have many, many years of expertise. Give me some ideas about what it's like to train things. What are things that typically trip you up? What are things that take a long time? What are things that are costly? And so it's also getting these folks to think in a new way, to have to tell you stuff early on so you can build it in early on. And that's just not a way that they think. So again, in terms of OSMED, these are the conversations we want people to have. Talk to the designers at the same time you're talking to the engineers, because they'll put them on as an afterthought. It's never going to happen. So this is part of it. It's a culture shift, really, about getting these conversations to be had earlier and knowing where the inflection points are for these things to really be cost drivers and sustainability drivers. Does that answer your question, David?
Yeah, so you'll be addressing that more in your group meetings and so forth.
I would love to. Yes.
We've been trying this for a long time. I mean, we were pushing the integrated product teams and all that back in phase B anyway, before the proposal and station. And I know what you mean about that push pull. Yeah. Also, I've observed the same 80-20 rule for setting risk. Mm-hmm. I wrote about the evolvable inner architectures. There's interesting stuff.
It is, because then you're looking at, all those paper architecture studies that we did for many years, right? It's saying, what are the important things to bring? What are the, I don't want to cover, 20% of the problems. I want to cover 80% of the problems with this stuff, right? And that's, Eric just left, but with the medical risk modeling, that's a huge piece, right? If I fly this one ultrasound device, look at all the conditions I can now potentially monitor and treat. Versus if I fly this other piece of equipment, I maybe only get a few conditions. So that whole process of scoping that throughout all the systems is enormous. So yeah, let's chat. Happy to have you connect. I can give you lots of materials if you don't already have them. And also happy to come talk to whomever that needs some Kool-Aid. We're happy to share it.
I didn't see an email address for you.
Oh, I'll put it in the chat.
Thanks.
Yep.
Let's see. All right. I think that is it for this hour. It is time. What a wonderful hour we spent with Dr. Jennifer Rochlis. Let's give everybody a round of applause for her incredible generosity with sharing her wisdom, her experience, and her vision of the future.
Bless you.
Thank you so much.
Yeah, and if anybody has a question, I can stay on another minute, or you can send me a text, or you can send me an email. I put my Advancing Frontiers email there. I also have an OSMED email. If you're already a member, you can DM me in Slack. So lots of ways to get a hold of me. But thank you all for coming. I hope this was helpful. I appreciate, Phnam, the conversation. I always enjoy talking to you and hearing your perspective as well. And you're such an excellent moderator and questioner. And so I know that these events are going to be really rich for everybody going forward. Thank you.
Thank you so much. Learning all the time. And for those who are not OSMED members, but we're very enlivened by this conversation, want to participate, want to write white papers with us, want to be part of the conversation, I recommend that you go on osmed.org/membership and see how you can join us and be part of all this. Thank you so much.
Thanks, everyone.